Welcome to the first deep dive into Project JAISIN, where we'll be talking about the refactor and how some of these more complex features work. I know there are a lot of bugs right now, but the general concepts will stay the same. And I'm going to be talking about the things that aren't as obvious when looking at the code. Like, I'm not going to be talking about how to make a website using Flask or other stuff because, well, that's well documented and less specific to this project. If there is a major consideration or problem that I encountered while making these, then I'll probably talk about them here. But there wasn't anything of that sort, unlike previous videos, so I'm only going to be focusing on things specific to this project today. So for the elephant in the room, the refactor. Refactoring is basically rewriting the code. This isn't something you want to do often because obviously it's a lot of work, but mainly people who were once familiar with the code become no longer familiar with it. But there are times when a refactor is really necessary in order to maintain the project. The reason I chose to refactor most of the project here was because there was a lack of structure, which made managing the flow of data between parts of the project very unintuitive and tedious to make changes to. Like, for example, I originally had a Discord bot here, and I would also have another half of the Discord bot here with the commands. Now, these were connected with each other, but they barely shared their dependencies, which would have resulted in something like this, where the Discord bot depends on each of these models and a bunch of other stuff. But same with the voice commands. And it's not like these were really located close together either. These were like very separate entities. Not only that, but there might have been also dependencies within each other, where maybe the text-to-text model had dependencies on the text-to-speech model, and same over here. And so you see, it starts to become this really messed up web of dependencies, where if I change some stuff in the text-to-text model, then I would also need to update the dependencies for the Discord bot, the voice commands, the text-to-text model, and all the other stuff. Updating one thing would require me to maintain everything else as well. This just isn't good for maintaining things because there's a lack of scope to everything and a high amount of coupling. This gets even worse if I factor in the web UI as well, which is our control board and needs to be able to control literally everything. So this would have dependencies here, this would have dependencies here, here, same things backwards as well. And just looking at this graph, it looks fucking ugly and it's terrible, and this is not how we should be doing things. We needed to refactor because this structure was horrible to try and maintain and horrible to try and debug even with a web UI. So I deleted all that and I decided to give it some semblance of structure. In order to do that, we have something called design patterns and architectures in software. These are basically well-defined strategies for connecting components to solve some sort of logistical issues. Each solves a different problem and can be combined with a larger system, but no one is a catch-all solution. You can go to Geeks for Geeks, that's pretty good for a lot of beginner resources. You can take a look through any number of websites that talk about types of software architectures or type of design patterns. But there's one that I want to specifically focus on, which is the one we use for the project now, the layered architecture. As the name suggests, components in this pattern are separated into layers of subtasks, and they are arranged above one another. Each layer has unique tasks to do, and all the layers are independent of each other. Since each layer is independent, one can modify the code inside the layer without affecting the others. This pattern can have any number of layers, but the most common is, well, the 4-layered structure. And this includes the presentation layer, aka the thing that the user sees and interacts with, the business layer, which is where all the backend logic occurs, the application layer, the layer that's in between the presentation layer and the business layer, as well as the data layer, where it contains the entire database. If you're familiar with full stack development, then this is more like the front end, the back end, the database, and the API. There are some very popular examples. This is basically how Linux OS is structured. This is your presentation layer, and this is where all of your applications will be running. JAISIN, all of the packages that I interact with, stuff like that. They all live inside the user space. We have another layer down here. This is like the business layer, and this is called the kernel space. The kernel is where the entirety of the operating system lives and works, and there's no way for any application in the user space to subvert the kernel space and reach hardware. It always needs to talk to the kernel space in order to reach the hardware platform. And in order for it to talk to the kernel space, it goes through the system call interface. And the system call interface is basically the API for the entire thing. So you can see this is a 4-layer structure as well. Everything is very well separated. You can have dependencies within each layer or things within the next layer above or below it. So this is basically what it looks like now. On our top layer, we have our front-end applications. We have our Flask app here, and I'm considering Discord bot with its voice commands to also be part of that. These are things at the very top that depend on JAI-SYN for all its functionality. They have no crosstalk between each other. They only go through the JAI-SYN layer to reach any of the other models and stuff. The JAI-SYN application layer, it manages a global configuration, which is shared amongst every single one of these models in order to determine how they should behave. Down here is all the models, all the plugins, and they're basically pieces of hardware that is called by that JSON application layer and strung together in order to perform certain things, like the text-to-speech pipeline. So basically the JAI-SYN application layer is the brains of this entire thing. It is the highway for information. And so if I ever make changes to the text-to-text model now, then all that would ever need to change is whatever depends on it. So the JAI-SYN application layer, I forgot to change these, the prompter and instructions stuff. I don't know. I'll get to these in a little bit. These top layer front-end applications, they don't need to exist for JAI-SYN to work. Everything down here in the hardware layer, they don't depend on each other and they all act on their own. So they don't really need the JAI-SYN application layer in order to function by themselves as individual components. So basically how this works now for development is whenever I need something for my Flask application or for the Discord bot, then I create a new endpoint within the JAI-SYN application layer, and the JAI-SYN application will handle all the logic. The Flask application does not know what's going on behind the scenes. It just knows that what it needs will come from the JAI-SYN application layer. All of this was done for the sake of organization and maintainability, but also in the future, I plan on separating each of these into their own different services. Each of these models may become their own service with their own API to better abstract things. The JAI-SYN application layer is basically already its own thing. And same with each of these, I may move them to their own separate projects, which you can optionally download and run. While we're at this high-level view of the program, I also want to talk about the design pattern we use to help create live playback of audio and responses to our front-end UI, the observer pattern. Between our application layer and our front-end presentation layer, there's actually more going on here. Right now, it only shows that there's a one-way relationship, but actually, the JAI-SYN application layer communicates with all front-end applications, regardless of what they are, using either the API, which is the main thing, but for these more complex features, it makes use of the observer design pattern. Now, I don't know why I like this design pattern so much. Maybe it's because it's the only thing I remembered when I first learned design patterns. But either way, this design pattern makes it so we can efficiently have a huge number of front-end applications using a singular JAI-SYN application layer and not have to worry about each one of them polling, aka asking for information updates from the JAI-SYN application layer, which would completely bombard that layer with so many expensive requests. Instead, the observer design pattern is effectively a subscription-based mailing list. Instead of customers, like the observer, emailing a company, like the subject, every single day for business updates, they can subscribe to their mailing list and the company will email them whenever updates come out. So there's less emails sent while the same information is getting out there. So inside of our code now, we now have this, and this is basically helping us implement the abstracted version of the observer design pattern. So this is the client, aka our observer, and this is the server, aka our subject. This is what's being subscribed to. Whenever a client is made, they first try and subscribe to some sort of mailing list or some sort of server. Inside of the server, it keeps track of a list of everybody that's subscribed to it. And whenever it is told to broadcast an event, it will go through all of the clients that are subscribed to it and send them this new information. It will send them an email saying, hey, here's the new data, do whatever you want with it. And it does not care what they do with it. You can see we have our broadcaster server inside of JAI-SYN. Whenever we're finished creating a response or we're finished canceling a response, it broadcasts this event, and wherever there's a client that's listening to this server, they will receive this request along with the data that's within it. We can look inside of the web UI, for example. We have this client that's listening to our JISON server and is handling specifically the response generated result. So whenever there's a response generated, it will tell all the front-end UIs that, hey, a response has been generated. You should try playing the audio now as well as creating the subtitles. That's basically what we have going on here. The concrete subject is our JISON application layer, and everything here is like the Discord bot as well as the web UI. I think that's enough for a high-level architecture, so let's get down into one of the components that saw significant changes, aka the text-to-text AI. If I come over to literally the previous version, if we look inside of our base worker for text-to-text, you can see that we're managing message history, we're managing the name, we are managing the prompt, we are managing everything inside of here. Really, all the text-to-text AI needs to do is generate responses. But even just scrolling through here, I couldn't tell where that was happening until I saw, okay, here it is. It's happening inside a call. But you have all of this extra stuff like add history, prune history, build script. What is all of this? I don't really need this to be here. And it's just making things a lot more complicated to look at. We can easily break this down into multiple classes in order to improve the maintainability without affecting performance in some way. So let's come over to the newest version that I've put out. And we now have this base worker, which is significantly simpler. You can call, you can get response, and you can inject a one-time request. And now instead of managing the prompt, the message history, and having all of those functions there, we now simply just have a prompter. And this prompter is where all of that is being handled. And even that is being composed of two different, classes called context and instructions. The idea between context is explaining what's going on to the AI inside of the prompt. So it's explaining what information is available to it, how to read that information. Instructions are actually the prompt themselves. So if you look at here inside of example, this is what our prompt looks like now. This is all you have to manage. But before, it used to be a lot more in explaining you will be responding to this dialogue, blah, blah, blah. Here's the dialogue structured. All of this should be the same from model to model, really. We're changing that so it's a lot more structured. If I come over to context, we're defining and easily expanding with many more different kinds of information with different headers. We can have Twitch chat, we can have one-time requests, we can have the script, Twitch events, all of this stuff, and include that information seamlessly into our application without having to rewrite that for every single prompt. This is just explaining how to handle that information, and this is just building out the context with all the information that's available to it. And because this is managing all the information that is available to it, it is also managing like the conversation history and in a lot more understandable manner. And the instructions themselves are a lot simpler, and it also allows for more dynamic prompts to be used. So we can change them out on the fly by changing the configuration on the fly. So now it's a lot more intuitive to manage different parts of the prompt, and the base text-to-text AI is also a lot easier to understand now. I think that's all for the big points I wanted to talk about in this iteration. There were obviously a lot of other structural changes, but they don't affect the applications as much as these. If you have any questions about the project, you can leave a comment and I will try to answer them there, or you can reach me anytime on Discord, details down below. I know this video may not be as edited as the other ones, but the main point is to kind of get a brief understanding of the actual system. If you really want to understand it for development, I'm always available, and I think it's more beneficial to explain things in that way. But yeah, that's all for now. Thanks for watching.